Welcome to my channels. In this video, we are going to determine if a network is reciprocal or passive. So let's take a look in this network. And this network is taken from one of our example, our previous example. Is a completely resistive network. The S parameter has already been derived, and this is the S parameter. And what we are going to do is to determine whether the network is passive, reciprocal, noisy. Yeah. Uh, so to begin with, what we need is to use this equation. Yeah, to determine the total power loss of this network. The total power loss can be determined using this equation, where power P stands for power, A for incident power, and B standing for refracted power. The total of incident power from all ports summed together minus the total power reflected from all ports is what the power loss in the networks. So in this case, we can rewrite this term. This term A of I, this means the incident power at port I. Yeah, we are looking for the magnitude square. So in this case, the magnitude square can be written as the product between the conjugate times the magnitude. That times the value A. So similarly, we can do the same for B. So this is what we get. So instead of using these algebraic equations to describe the power, we can also use matrix. This means we don't really need to use the summation sign here. So let's do it. What we can do is we use a matrix, which stands for the row matrix for the incident power for different ports, and B matrix to represents the refracted power for all the ports. And remember, right, this guy here can be written as the conjugate of the whole matrix, and then transpose, and then times A. Okay, now you should make it more clear. Yeah, so from here to here, it should be very clear. And we don't use any summation term. We just use this. So this is not the variable A. Instead, this is A matrix, and then we conjugate it together, and then we transpose it, and then multiply by A, which is also a matrix. And we can do the same for B. And remember, right, I'm making a mistake here, and this is minus. And if we continue with this process, we can use this formula, this equation, to substitute all the variable B here. all the matrix P here. So we do that and we do that. And that's why we get this equation. And now the final step is to um, simplify it. Sorry, I need to correct this sign. So we continue with this process. We simplify this formula. And again, this should be minus. This is the typo, the bad handwriting. Now, we are now ready to take off now. We can further simplify this equation by taking out the A matrix out of this bracket. And this is become I, the unitary matrix. And now we can further simplify this. So in this case, for a network to be passive, P has to be positive. To be passive, P should be greater or equal to 0. 0 means zero matrix, and P is a matrix. And in this case, we can quickly conclude that this middle term here has to be greater than 0, has to be equal or greater than 0. And we can say so this is what we can get. We can say here, yeah. And if the network is lossless, this means the power loss from the power loss from the network is 0. So in this case, I can say for a network to be lossless, we should get this. So this is the criteria for the network to be lossless. Now this criteria make sure the network is passive. If the network is not passive, then you will never get this. You will end up with a value greater than 1. So all the elements here has to be carefully considered. Okay, now we are now ready. Now we are going to use this technique to determine whether the example that we are dealing with is reciprocal, passive, or lossless. So first, we write down the S parameter. The S parameter here is Now, first of all, for a network to be reciprocal, S12 Sij must be equal to Sji. And there is no other way to determine if the network is reciprocal or not. So clearly, in this case, S21 and S12 are the same. So we can say the network is reciprocal. Reciprocal. Now the next check that we need is to check the power. And we have already now we need to find out S conjugate. None of the value here is complex. So whether it is conjugate or not remains the same. So and now we are going to find out S transpose. And again, if we transpose it, then this one become and this one become so there is no change. And now we are going to determine S times S. And let's see what we are going to get. And if we do that carefully, and I've already calculated the values. So it's 20991728 1728 and 2747. Now it's very clear now. For sure, the network is lossless. And I would also say the network is not lossless. And how about passive or active? And we can see from the diagonal here. So they are less than 1. So the network is passive. The network is passive. So I hope this is clear enough for you. And in the next example, in the next video, I'm going to examine one more case on reciprocity and passivity. Thank you.